Okay, so question number 8. In right triangle ABC, right angle at C, M is the midpoint of the hypotenuse AB. So in right triangle ABC, M is the midpoint of on the hypotenuse AB, and its right angle at C. C is joined to M and produced to the point D. C is joined to the point M and produced to D such that DM and CM are equal. So DM and CM are equal. And P is joined to point B. Now you have to show all this. Okay, now let's see. So let me draw the figure. In triangle ABC, angle C is 90. It is right angle at C. That means angle C is 90. And M is midpoint of AB, and CM is produced to D. CM is produced to D, and DB is joined or BD is joined, and CM and DM are equal. And what is told, M is the midpoint of, in the question it is told that M is the midpoint of AB. So AM and BM will be equal. AM and BM will be equal. And in the question it is given that CM and DM are equal. CM and DM are equal. CM is equal to DM. Okay, now you have to prove all this. Okay, let me write the given. In right triangle ABC, it is right angle C, so angle C equal to 90. Then M is the midpoint of the hypotenuse AB, so M is midpoint of AB. Then C is joined to M and produced to D such that DM equal to CM. So we can write CM or DM equal to CM. And what? The point D is joined to B. So we don't have to write that. This much if you write, that is enough in the given. Okay, to prove what? In the given, we write only the important things. We just write in short. And you have to show all this. That is number one. Number two is angle and number four is CM equal to 1 by 2 AB. So we are going to show all this. Okay, first, what are you going to show? Triangle AMC, we have to show this. Triangle AMC is this, and marking by red. And triangle BMD is I'm marking by green. So you have to show these two triangle congruent, and to show these two triangle congruent, we need to show 3 part of one triangle equal to 3 part of another. Now here in these two triangle, what do you have? We have already AM equal to BM, since M is the midpoint of AB. Again, CM is equal to DM. Why? It is given in the question. And that means what? We have two sides equal. Now in between them, we have the angle this and this. We have the angle this and this. Are they equal? Yeah, they will be equal. Why? They are vertically opposite angle. We can mark this one as 1 and this one as 2. Okay, draw the figure, write it given, and once you're done, you can raise your hand, because I need to rub. I need the figure, so I'll rub and we'll move. Yeah, if you're done, you can raise your hand, because I'm going to rub this. Okay, so it is written. That means I'm going to rub the first part. Now we're going to show the triangle. First thing is we're going to show the triangle AMC congruent to triangle. We have to show the triangle AMC congruent to triangle BMD. So we'll start the proof with. Since we are going to show this to triangle congruent, so we'll take the triangle AMC. So we'll write in triangle AMC and triangle BMD, and then we'll take and we'll see in triangle AMC and BMD what we have. We have what? Side angle side of one triangle equal to side angle side of another one. So that means they will be congruent by SS. So now in this two triangle, what do you have? First, we have AM equal to DM. Why? Because M is a midpoint. It is told in the question that M is a midpoint of AB. So we can take AM equal to BM. Why? Since M is midpoint of AB. Then again, can you take angle 1 and 2 equal? Yes, we can take angle 1 and 2 equal, because they are vertically opposite angle, and vertically opposite angles are always equal. Then again, what you can take, we can take CM equal to DM. CM equal to DM. We can take CM equal to DM, because it is given in the question. CM is equal to DM. So what you're getting, side angle side of one triangle equal to side angle side of the another one. So the triangle will be congruent. So therefore, we got side angle side of one triangle equal to side angle side of the another one. So the triangle AMC will be congruent to triangle BMD. By what congruency? SAS congruency. Okay, now since these two triangles are congruent, so we can take this AC and BD equal by simplicity. And same way, we can take, we'll take these two angles, this and this. Say opposite to CM, we have this angle, that is, I'm marking 3, and opposite to DM, we have this angle that I have marked 4. Now, if you see 3 and 4 are opposite to CM and DM, and we know CM and DM are equal, so we can take 3 and 4 also equal by simplicity. Okay, so let's take it. Okay, so after showing this to triangle congruent, what you can take? We can take AC is equal to DP. And we can take angle 3 equal to angle 4 by CPCD. So both of them will be equal by CPCD. You can mark this one as 1 because we are going to use this to show the other thing. Then angle 3 and 4 are equal. Now angle 3 and 4 are equal. If angle 3 and 4 are equal, what does it mean? Alternate angles are equal. If you see 3 and 4 are in the Z formation, so they are alternate angles. So if they are equal, the line, we can take DB and AC parallel. 3 and 4, angle 3 and 4 are equal, so we can take DB parallel to AC. Therefore, DB parallel AC. Why? Since a pair of alternate angles are equal. Since a pair of alternate angles are equal. Okay, so we have shown DB parallel AC. Now, next is what you have to show. You have to show the angle DBC right angle, DBC right angle. Now, to show this angle DBC right angle, what do you have to show? To show DBC right angle, what do you have to show? You have to show this angle DBC 90. Now, how to show this? Now, we have already now shown that these two lines are parallel. This is BD or DB and AC are parallel. DB and AC are parallel. So we can take these two quantary angle, their sum equal to 180. So we can take DBC and ACB equal to 180. DBC and ACB equal to 180. So now we can take again what angle DBC plus angle ACB equal to 180. Why? Because they are quantary angles. Okay, then we can put the value of ACB. ACB, we know it is 90 because angle C is 90. Put it. It is given in the question that it is 90. Okay, now from this we can solve it. We can find DBC. So angle DBC is how much? 90. So that means we have shown angle DBC right angle. Then this one mark it as 2 because we are going to use it afterward. And after writing this much, if you're done, you can raise your hand. Right after this and raise your hand because I'm going to rub it and there is something more to show. Okay, so I think it's done. So I'm rubbing the first part. Okay, now next is what you have to show is you have to now show triangle DBC congruent to triangle ACB. DBC, that is this triangle, DBC and ACB congruent. Okay, so we have to show this triangle DBC, that is this, and triangle ACB, that is this. So we'll take these two triangles and we'll show that they are congruent. Now, how to show? Now we have already shown that DB is equal to AC in one. In one, equation number one, we have already shown DB equal to AC. Then we have already shown that DBC is 90. Angle DBC is 90, angle ACB is 90 because angle C is 90. So we have again angle 1 angle 90, and this BC is a common side for both the triangle. So what do you have in this two triangle? DB equal to AC. Then again angle DBC we have shown equal to angle ACB, both are 90 each. And again we have one side equal, or one side common for both the triangle. So what you have, side angle side of one triangle equal to side angle side of another triangle, so the triangle will be congruent. So we can take it. Now we're going to show in the triangle DBC and triangle ACB congruent. So first take the triangle in triangle DBC and ACB. What do you have? First DB equal to AC from 1, we have shown in 1. Then we have angle DBC equal to angle ACB. Both are equal to 90. Both are equal to 90. And DBC we have shown equal to 90 in 1, so in 2. So from 2, and ACB is 90. It is given in the question. So given. Again, what do you have? BC is equal to BC. That is common. Therefore, triangle DBC will be congruent to triangle ACB by what congruency? Side angle side. Side angle side. So the triangle will be congruent by SAS congruency. And since the triangle are congruent, now we have to show one more thing, that is what CM equal to half of AB. Now we have to show CM half of AB. Now to show this, first we'll take DC and AB equal. Therefore, DC equal to AB by what? By CPCT. We are taking them equal by CPCT. The triangle are congruent, and if you say DC is a side opposite to angle DBC, and AB is a side that is opposite to angle ACB, and we know both the angles are equal. So this DC and AB also will be equal. We know these two angles are equal, and opposite to this angle, equal angles, we have DC and AB. DC is opposite to this, AB is opposite to this, and we know both these two angles are equal to 90. So we can take DC and AB equal by CPCT. Now we know what, if you have two sides opposite to the equal angle in congruent triangle, then we can take them equal by CPCT. We have already shown the triangle congruent, so we can take DC and AB equal by CPCT. Okay, now again, we know that CM and DM are equal. So instead of this DC, this whole, we know that two parts of the DC, that is DM and CM. We know CM and DM are equal. It is given in the question. And these are the two parts of the same side, DC. So instead of DC, I can write what? 2CM. Instead of DC, I can write 2CM. We know that two parts of DC, that is DM and CM, are equal. So instead of the whole thing, that is DC, I can write twice of any part, CM or DM. I can write twice of CM, or I can write twice of DM. But I need to show CM equal to something, so I am converting this one to 2CM. Why? Since we can write DM equal to CM. It is given in the question. Then from this, find CM. CM will be what? AB by 2, and AB by 2, we can write it half of AB. AB by 2, I can write half of AB. So that is what you are asked to show, so hence proof. Okay, once you are done, you can raise your hand. Once you're done, raise your hand. Okay, fine. So it is done. Question number 9 is similar type, so I'm not doing, I'm leaving it. Then we'll move to the next. Before moving to the next exercise, you have to know some more theorem. First, let's see the theorems. We'll see now some properties of triangle. We are going to see some properties of triangle. Okay, now first one is isosceles triangle property. We're going to see isosceles triangle property. And that is what? That is theorem 7.2. That is theorem 7.2. Now, what is that? Angles opposite to equal sides of a triangle of an isosceles triangle are equal. And this one may come in the exam, so we have to prove it. So if it comes in the exam, the question will be prove that angles opposite to so if in the exam, if this theorem comes, it will be prove that angle opposite to the equal side of the triangle are equal. Okay, next we're going to see the proof, but right after this, and raise your hand because I need to rub, and we are going to prove this particular theorem. And this theorem is also called isosceles triangle property. This property of this theorem, we can just say it as isosceles triangle property. Angle opposite to the equal side of the triangle are equal. So we can say this theorem as isosceles triangle property also. Okay, so I'm rubbing it. Okay, we're going to prove it. So we'll take a triangle. So it is an isosceles triangle. The sides are given equal. And you have to show the angle opposite to this equal side are equal. So you have to show angle B and C equal. So given will be in isosceles triangle ABC, AB is equal to AC, to prove what? Angle B equal to angle C. Now to prove this, we need a construction. We need construction. So what are you going to draw? We are going to draw AD bisector of angle A. We'll draw AD bisector of angle A. So that means it will divide, AD will divide the angle A into two parts. So mark this one 1, mark this one 2. So construction is draw AD bisector of angle A. So sometime we need construction, and if you draw some construction, you have to write it. Construction is we have drawn what AD bisector of angle A, then proof. Now we'll show these two triangle congruent. Say we have to show what angle B and C equal. Angle B and C will be equal. They are not equal. We have to show it equal. They are not equal. We have to show it equal. How to show it equal? If you can show these two triangle are congruent, if you can show these two triangle congruent, then we can show angle B and C equal because they are opposite to the equal same side. Angle B is opposite to AD, angle C is opposite to AD. So if you can show these two triangle congruent, then we can show angle, or we can take angle B and C equal. So to show this, we'll take the triangle ABD and triangle ACD, and we'll see what you have. In triangle ABD and ACD, what do you have? We have AB and AC equal. It is given in the question. Then we have angle 1 and 2 are equal. Why? Because AD is a bisector of angle A by construction. And we have AD common for both the triangles. So AD equal to AD. So what do you have? Angle side, side angle side of one triangle equal to side angle side of another one. So these two triangles will be congruent. So take it. In this two triangle, what do you have? AB equal to AC. It is given in the question. Then again, angle 1 is equal to angle 2. Why? Since AD bisects angle A by construction. By construction. Again, we know AD is equal to AD. Take it, common. Therefore, what are you getting? Side angle side of one triangle equal to side angle side of the another one. So the triangle ABD will be congruent to triangle ACD by what congruency? SAS, side angle side. So SAS congruency. And since these two triangles are congruent, so what you can take? Say opposite to AD, we have angle B and angle C. Now the triangle are congruent, so we can take this angle B and C equal. So angle B equal to angle C, we can take it equal by what? By simplicity. Since the triangle are congruent, we can take the corresponding angles equal. Why they are corresponding angles? Because they are opposite to the same side AD or equal side AD, or they are opposite to equal sides. So they will be equal. Okay, once you're done, you can raise a hand. Once you're done, raise a hand. Okay, so I think it's done. So let's rub it. Now we'll see next is theorem 7.3, but the proof is not required. So we'll just write the statement. The size opposite to equal angles of a triangle are equal. Okay, so what does it mean? If we have a triangle, and if the two angles of the triangle are equal, then we can take the side that are opposite to them equal. So if angle B and C are equal, we can take AB and AC equal. So if in triangle ABC, angle B is equal to angle C, then what you can take? AB equal to AC. So if the two angles of the triangle are equal, then the side that are opposite to them, we can take it equal. Opposite to B, we have AC, and opposite to C, we have AB. So AB and AC, we can take it equal. And both these two theorems are also known as isosceles triangle property. Both these theorems are what? The properties of isosceles triangle. Okay, once you're done, you can raise your hand. So theorem 7.3, the proof is not required, so we're not proving it. I'm just writing what does it mean for your understanding only. So if in triangle angle B and C are equal, we can take the side that are opposite to them equal. That is by isosceles triangle property. Okay, so let's see something a little bit more. So in a triangle, if the two sides are equal, so in a triangle, if two sides are equal, we can take the angle opposite to them equal, angle that are opposite to them equal, angle B and C, we can take it equal. Same way, in a triangle, now this is just opposite to number one. In triangle ABC, if two angles are equal, angle B and C are equal, so what you can take, we can take the side opposite to them equal. And both we can take it by isosceles triangle property. These properties are what? Isosceles. Both these properties are what? Isosceles triangle property. Both these properties are what? Isosceles triangle property. So if we have two angles equal, that we can take the side opposite to them equal. And if you have two sides equal, we can take the angles opposite to them equal. And if you have two angles equal, we can take the side opposite to them equal. Okay, and we can take them by isosceles triangle property.